Okay, so we have already seen the process of factorizing different expressions. For example, if I have got x squared minus 2x minus, let's just say I've got 24. So if I factorize this, just factorize this, you should be able to get x squared minus 6x plus 4x minus 24, and it is going to give you x common and then x minus 6 plus 4 is common and x minus 6, and you can see that I've got two factors, x minus 6 and x plus 4. So x squared minus 2x minus 24. If I factorize this, I'll get x minus 6 times x plus 4. So I've got two factors here, 1, 2. So both of these are the factors. And this thing over here was the actual polynomial. Okay?
Yes, sir.
All right. Now, what is actually a factor theorem? And what do we actually mean by a factor theorem? So let's just actually begin with the factor theorem. Before I start with the factor theorem, I want you to do one thing. Can you plug in plus 6 into this function? So for example, I say the function is f of x equals x squared minus 2x minus 24. So can you find out f of 6? What will I get?
-1.
So you think 6 squared minus 2 times 6 minus 24 equals to -1?
Oh no, 0. I put in 25 instead of 25.
Okay, so that is 0.
0.
Okay, now that's a very important point here. We're coming to this point. Okay, now can you find out f of -4?
-32.
Sorry?
I got 0.
0. So f of -4 whole squared minus 2, it's a -4, minus 24, and the answer is 0. That's again a very important point to note here. You won't get 0 as an answer for any other number for this polynomial. These are the only two numbers which will give you 0. Now, where did I get these two numbers from? 6 and -4. Where did I get these two numbers
Sir,
from?
can you repeat? From the factors.
From the factors. And are they the exact numbers from the factors or what?
No, the sign, it's the opposite sign.
Yes. So I've changed the signs, put it into the function, that gave me 0. And I changed the sign for this one, put it in the function, and that gave me 0 as well. This is actually what a factor theorem is. That now there are two perspectives to look into the factor theorem. One perspective is if you plug in any particular number into the function and it gives you 0. It gives you 0. So for example, you have any polynomial. Let's just say you've got ax squared plus bx sorry, ax cubed plus bx plus cx plus d, that's f of x, for example. And if you plug in a number k into this polynomial, and you see that the answer is coming out as 0, which that will mean, then this means, therefore, x minus k would be one of its factors, because you get only 0 from the factors. You only get 0 by a number which is a part reverse sign of one of its factors. Got it?
Yes, sir.
So if I tell you that I don't know what are the factors of any particular polynomial, so if I give you a polynomial and I ask you to plug in a particular number into it, you plug that into it, let's just say you get a non-zero number, then it would mean that then x minus that number is not a factor of that polynomial. But if you get 0 from that number, so let's just say you put k into this, and you're actually getting 0 after solving this, then that would mean that x minus that particular number which you plugged into that is actually a factor of that polynomial. Okay?
Yes, sir.
So that's one perspective of looking into this. Okay? That's one perspective. That in this perspective, I was provided with a number, I plugged it into the function, and the answer came out as 0. Therefore, from there, I deduced that change the sign of that number, put it with the x, then that factor that is going to be one of the factors of the given polynomial. Let's just say, and now let's just look into the another perspective. In this case, we'll be doing opposite of the first perspective. If I have something like this, x minus k, then if I know that it is one of the factors of a given polynomial, so if this is a factor of a given polynomial, therefore, if I know that, then k, f of k will always give you 0. The second perspective we have already verified. I told you these two are the factors of it. We change the sign. Okay. I told you to test it, but next time, by knowing this factor theorem, you don't have to test it. So over here, you tested it because I was about to teach you this. But now you don't have to test it. If I tell you that these two are the factors, you should know if I put plus 6 into this, it is definitely going to give me 0. And if I put minus 4 into this, it is definitely going to give me 0. So these are the two perspectives of the factor theorem. Got it?
Yes, sir.
You got it? Okay. Now, for example, if I have a function two x cubed minus 7x squared plus 9. Okay, 2x cubed minus 7x squared plus 9. If this is a polynomial, and if I ask you to find out f of 3, what would it be? Can you do that?
Mm. 0.
That's 0. So f of 3 is 0, which means, therefore, x minus 3 is a factor of f of x equals 2x cubed minus 7x squared plus 9. Got it?
Yes, sir.
Because when I'm plugging in 3 into this function, it is giving me 0. Okay?
Yes, sir.
Now let's just say I've got another function as 4x cubed plus 8x squared minus 9x minus 18. And if I give you the factors of the same function, then let's just say the factors of this function, they are x plus 2 times 4x squared minus 9. Now, from the factors, now we're talking about the second perspective. The first example I gave you, this one up here, is of the first perspective, that we plugged in a number and it gave me 0. From there, I deduced that that number, changed the sign, put it with the x, is a factor of the polynomial. Now, I have given you the factors from here. I'm going to tell you a number which is going to give me 0. So, what number is going to give me 0 for this polynomial?
-2.
Yes. So this means g of -2 will definitely give me 0. That came from this factor. Okay?
Yes.
I'm not going to talk about this one for now. Definitely we can deduce the same kind of result from here, but I'm not going to look into it for now because this is not completely factorized. If you look at this one, you should be able to factorize this further. Okay?
Yes, sir.
Don't worry about it, that how did I get the factors of this? We'll be studying that today, that how to factorize the polynomial. We kind of studied this in a previous lesson, that once you get 0 as a remainder, then these two are the factors of this polynomial. Okay?
Yes, sir.
Is this clear?
Yes, sir. It's clear.
Okay, now sometimes you're not provided with this number. Over here, I gave you the number to plug in into the function, which is because I knew it's going to give you 0. Sometimes you have to think of it. When you look at a complex function like this, it's not very easy to think of the number directly. So then you need to do, what you need to do is try hidden trial first. Okay, so you plug in different numbers. So whenever you're doing that, it's always good to start from 1 and then put -1 and then put +2 and then -2 and +3 and then -3. You can keep on going like this, but 99.9% you will get your answer from either of these. Okay?
Yes, sir.
All right. Okay, now let's just try an example here. Let's just say I've got a polynomial here. F of x equals x cubed plus 6x squared minus 9x minus 14. Okay, in the first part, the examiner asks you to, let's just say, ask you use the factor theorem to show that x minus 2 is a factor of f of x. That's the exam question. So here's another exam question. The same question is part B. We need to use the factor theorem to find another factor of f of x. Okay? Got it?
Yes, sir.
All right. So first of all, we need to use factor theorem to show that this is a factor. If this is a factor, then f of 2 should give you 0. So let's just verify it, okay? So let's just do part A first. If x minus 2 is a factor, then f of 2 should be equals to 0. Therefore, let's find f of 2. 2 cubed plus 6, 2 squared minus 9 into 2 minus 14. So let's just calculate this. 2 cubed plus 6 times 2 squared minus 18 minus 14, which is actually 0. So x minus 2 is a factor of f of x. Got it?
Yes, sir.
Okay. Now in part B, it's asking use the factor theorem. Use the factor theorem to find another factor of f of x. So we'll be using a factor theorem to find another factor. Okay, now that is very important. So let me just take you back to the same point. So in order to know a factor, we need to plug in the number into the function and see if it is giving us 0. If it is giving us 0, from there we can write down a factor. The examples we've done up here, I gave you a number 3 to plug it into the function. That number was given to you by me. Okay, so when you plugged it in and you worked it out and you saw that it is actually giving you 0, then you change the sign, put it with the x. That means that x minus 3 is a factor of this. Over here, examiner hasn't not given us any of the numbers to plug it into the function. Okay, now we need to find that out on our own. As I stated up here, whenever this is the case, you start plugging in the numbers, starting from 1, keep on going like this, start plugging in one by one, and then see which of these number is giving you 0 as an answer. Whatever number is giving you 0 as an answer, that will be your jackpot. Okay, now the best thing to do is, now definitely you need to show your working in your exam. The best thing to go about is, now that write down the function into the, put the function in your calculator first. The x cubed plus 6 x squared minus 9 x minus 14. So that's the function. Now I'm going to calculate this function for different values of x starting from 1. So when I put 1, the answer is negative 16. Okay, so 1 is not my shot. So I'm going to go for, I'll do the calculate again. I'll hit calculate button again. I'm going to put x as minus 1. Now that is 0. So negative 1 is actually giving me 0. All right, and that was for me. Okay, now I'm going to use, definitely I need to show the working. Okay, so I'll be doing, starting off from 1. So this is actually a satisfaction for me. Now I should know where should I stop. So I know now even if I start from 1, where do I have to stop? Maybe you come across a question where you have to go up to here. So if you're using calculator, from there you will realize quickly that how far you have to go. But you need to start plugging in from here in order to show your working, that you have actually plugged in different numbers to find that out. Okay, now let's just start off with that. So let x equals 1. So I'm going to put down the function here. So f of x equals x cubed plus 6x squared minus 9x minus 14. Okay, so let x equals to 1. So therefore, f of 1 is 1 cubed plus 6, 1 squared minus 9 to 1 minus 14. So if you remember, when I plugged in 1 into the calculator, it actually gave me minus 16. Okay, so this is of no use for me. Okay, so I'm not going to stick to it. Now, let x equals -1. So I'm going to plug in -1 into the given function. So f of -1 equals -1 cubed plus 6, -1 squared minus 9, -1 minus 14. I know this is actually giving me 0. So the number which is giving me 0, from there I can conclude what is going to be my factor. So therefore, x minus -1, or just simply change the sign and put it in there. So if I change the sign, that is going to give me +1, is another factor of f of x. Got it?
Yes, sir.
So is this concept clear?
Yes.
So this was a factor theorem, and there are two perspectives of the factor theorem. So let me just box this off. Okay. The next thing is remainder theorem. But before jumping to that, let me just quickly tell you both perspectives one more time. One of the perspective of factor theorem is you plug in a number. That number you can decide starting from 1, -1, 2, -2, 3, -3. Whatever number out of these is going to give you 0. From there, you can write down a factor of that particular polynomial. Another thing, if I tell you that this is the factor of a given polynomial, from there you simply change the sign, put it in the function, you should know that is definitely going to give you 0. So these are the two perspectives of the factor theorem. Okay?
Yes.
All right. Now moving on towards the remainder theorem. Okay?
Yes, sir.
As the name suggests, in this one, we will be having remainder at the end of the division. So it's something related to that. Okay? But over here, we won't be actually dividing. We just know that we will be having a remainder at the end. Okay?
Yes, sir.
Okay, so I'm going to take an example from up here. All right, so let's just take the same example. Okay, now the question is, if I divide with one of its factors, what would I get at the end? Means if I put x squared minus 2x minus 24 inside and use one of the factors as the divisor, what will I get after a long division at the end?
Zero, because it is a factor.
Yes, 0, because it is completely factorizable polynomial. Okay? It's a
Yes.
completely factorizable polynomial. But what if it is not a completely factorizable polynomial? Or what if I divide this with number with a, let's just say if I divide, okay, now these are the two factors of it. If I divide this polynomial with either of these, it's definitely going to give me 0 at the end. But what if I divide the same polynomial with something which is not a factor? Let's just say I divide it with x minus 5, then definitely I will be having a remainder at the end. Okay?
Yes.
Now, how would I know about that remainder? That's what a remainder theorem suggests. Okay, now let's just talk. Let me just give you a general terminology here, then I'll talk about that. So, if I have a polynomial f of x, okay, and let's just say if I divide that polynomial with x minus a, okay, then remainder would be a. Where did I get a from? Yeah. Oh, sorry, not a, not just a, f of a. Okay.
Yes, sir.
So that is going to be the remainder. Now, this number, change the sign, plug it into the function, whatever value you get, that would be your remainder. Got it?
Yes.
Okay, now you may see this thing somewhere in the book written as f of x equals x minus a times 2 of a plus f of a. That's exactly the same thing which is, oh sorry, f of a. That's exactly the same thing which is written up here. What is it? The f of x, you divide this with this, you get another factor number which is on top, and that's the remainder. Now let me just give you an example so that you can understand this in a better way. So I'm going to copy down a question which we did the other day, which was not completely factorizable, and we got 40 at the end, this one. Okay, so let's just bring this and solve this. It's already solved. So I'm just going to copy it down here. Okay. So this is a polynomial. So this is f of x. So I'm going to mark this as f of x. In this case, okay, this is x minus a. Okay.
Yes, sir.
This is q of x. If I multiply this and add this, you get all this. Okay, and this thing at the end, that's f of a. All right, now what does it mean? I mean, if I plug in minus 3 into this function, this is f of x, okay? If I plug in minus 3 into this function, I should get 40 as an answer. That's what it said. See, this is minus a, that's f of a. F of a means you plug in this number with a change sign into the main function, and that's the result what you get.
So, sir, when you're writing this in factor form, how do we include the remainder?
How do I do what?
Include the remainder in the factor form of the polynomial.
You do it like this: x plus 3 times x squared plus 3x minus 18 plus 40.
Okay, got it, sir.
So, got it? So,
Yes.
this, okay, let me just, the polynomial was x cubed plus 6x squared minus 9x minus 14. Now that's x minus a, which I've written up there. X minus a. This is q of x. Means that's another function plus that's f of a. Means change the sign of this, plug it into this function, you should get 40 as an answer. Like that's why it's written as f of a. So that's what a remainder theorem is. Okay.
Yes, sir.
Okay, so you may have, okay, if you remember the polynomial division, that is why I brought down this example. So, um, okay, now, x minus a times q of x plus f of a. Yeah, that's it. I think this is what you need to remember. Now, how can we use these questions to solve? Now, if there is a remainder at the end, okay, so the remainder theorem will save you. Instead of solving this all the way down in order to know what is the remainder, you can do it directly. Okay, so as I told you, this is 40. You can get 40 directly from here. You simply change the sign, put it into the polynomial, you should get 40 as an answer. Let's just try that. So the function is f of x equals x cubed plus 6x squared minus 9x minus 14. And I want you to divide this with, what was it? X plus 3. That I'm telling you that if you divide this with this thing, you're definitely going to have a remainder at the end. What would be that remainder? Okay, now all I have to do is change the sign from here. What do I get?
-3.
-3. So as per remainder theorem, f of -3 should give you the remainder. So let's just find that out. So simply we'll do f of -3 equals -3 whole cubed plus 6, -3 squared minus 9 times -3 and minus 14. So let's just work that out. So -3 whole cubed plus 6 times -3 whole squared plus 27 minus 14. And that is actually 40. So without doing the long process of long division, I came to the conclusion directly. Got it? So that's what a remainder theorem is. Okay? And you'll be using this method if you're interested in the remainder of the problem. You're not interested in the q of x. You're provided with a polynomial. You're provided with a divisor. And the examiner asks you about the remainder. So you don't have to do the long division process to get to the remainder. Simply use this formula and directly use the remainder theorem and directly know the remainder of it. Okay?
Yes, sir.
Okay. Now you can use this to find out the unknown coefficients in the polynomials. Same idea. Now this is, I'm moving towards the complexities. Now, for example, okay, let me just work out the base. Let me just give you one more question for you to do it. Okay? I want you to tell me the remainder from x squared minus 2x divided by -3. So I'll leave this concept right in front of you so that just in case we want to refer it back. This is a polynomial. I want you to divide this with x minus 3 and tell me what the remainder is going to be without doing the long division process. Just use the remainder theorem in order to work that out.
Sir, I'm slightly confused. Can you do this one?
Okay. What's the divisor over here? You're dividing by what?
X minus 3.
Change the sign.
Plus 2.
Put it in here, you will get the remainder. That's what I will explain up here. You see, this was polynomial. This was the divisor. I wanted to look for the remainder. All I did, change the sign, plugged it into this polynomial, worked it out, and I got the remainder. Okay?
Okay. So we'll plug positive 3 into the
Yeah, into this thing.
3.
3. Nice.
Yeah,
So if you
so
divide it with this one, the remainder is
2.
3. See, you don't have to do the long division. Otherwise, if you don't know the remainder theorem, this is what you'll be doing. X squared minus 3x, change the signs. Cancel out. Minus 2x plus 3x, what do you get? X. Okay?
Yes.
Okay, now x times 1, and then x, and then minus 3. Change the signs, and you have 3 at the end. So without doing the long division process, you came to know about the remainder directly by applying a remainder theorem. Okay?
Yes.
Got it?
Got it.
Now moving towards a little bit complexity in it. Okay, now you can use the remainder theorem in order to work out the unknown coefficients in the polynomial. So I'm going to give you a polynomial of, like a simple polynomial of the same style of the two terms. Okay, now let's just say I have a polynomial x squared plus px, and I'm dividing this with a divider. The divisor is x minus 2. Okay?
Yes, sir.
I'm telling you the remainder. If you divide this with x minus 2, the remainder is 8. Okay, the remainder is 8. Now work out the value of p. Okay, now how would you actually calculate the remainder? It's given to you, but how would you find it out? Change the sign of it, put it into the function, and you will have your remainder. So what should I plug it into this one?
Positive 2. Yes.
Positive 2, which means f of 2 should give me 8, isn't it?
Yes.
So let's find out f of 2. So 2 squared plus 2 times p equals 8. Now we can work out the value of p from here. So 8 minus 4 is 4, and p is going to be equals to 2. Okay, easy?
Yes.
Okay, now sometimes you may get harder problems with multiple unknowns. This was just one unknown here. Okay, so multiple unknowns, there definitely you'll be applying the concept of simultaneous equation in order to work that out. But this is how you'll be creating an equation. Okay, is this clear?
Yes.
You create one equation like this, you create another equation exactly by using the same process, and then solve them simultaneously. We'll solve a question like that. Okay, now let's just bring this remainder theorem into a final shape. Okay?
Yes.
If I have a function f of x, any function like this, okay? Whatever it is. And if I have a divisor, which is ax plus b, up to now, I've been using divisors of type x minus a only, isn't it?
Yes, sir.
Okay. So let's actually minus b would be better here. Ax minus b. Then remainder will always be f of b over a. B over a. Okay, now how did I get b over a? First of all, tell me, if the divisor was x minus 3, what was the remainder? Like f of 3, isn't it?
Yes.
How would you calculate remainder? By using f of 3. Where did you get 3 from? You change the signs of it. Okay, that's what I taught you. But what's actually going on behind the scenes? You put that thing equals to 0 and work out the value of x and then plug it into this. The shortcut is normally, that's what we tell you, that change the sign and plug it into this. Now apply the behind the scene formula on this one and make x the subject. Okay, now ax minus b equals 0. So if I want to work out x, that's going to be b over a. That's why I'm plugging it into this one. Okay?
Yes, sir.
Got it?
Yes, sir.
So either you can just remember, whenever you get something of this type, change the sign of this b, that's positive, right? And make this the denominator of that. Okay?
Yes.
All right. Now we are going to, we're still looking into the process to evaluate the polynomial and the value of x that makes ax minus b or whatever 0, but it's not necessarily, it has to be an integer. So we don't, it's like, it can be fraction, it can be a decimal, something like that. It doesn't have to be integer all the time. Okay?
Yes.
All right, now earlier I talked about the simultaneous equation, so I'm going to do a question of that nature. So let's just say I've got a polynomial p of x, and it is x to the power 8x to the power 4 plus ax squared plus bx minus 1, where a and b are the integer constants. So there are integer values, the examiner has specified it. So a and b are integer constants. Okay? Now, the next information which is given to you by the examiner is when p of x is divided by x minus 1. So if I divide this polynomial with this x minus 1, the remainder is 9. Another information is when the same polynomial is divided by 2x minus 1, the remainder is 1. Now we need to find, and examiner is asking you to find A and B. Okay, this question is exactly same as this question which we did up here. The only difference is it's one unknown here. Okay, B. Over here I've got two unknowns, A and B. The process is exactly the same. So if P of x is divided by this x minus 1, the remainder is 9. So which means if I change the sign of this, what would I get?
Positive 1.
1. So which means P of 1 should give you 9, isn't it? P of 1 should give you 9. Change the sign, plug it into the polynomial, and this should give you the remainder, which is 9. Got it?
Yes, sir.
Also, and let's just talk about this one. Okay, change the sign, make this a denominator. What would I get? Change the sign, make this a denominator.
1/2.
1/2, which means P of 1/2 is going to give me 1. Okay, so if I change the sign of this, make this denominator, so I got 1/2, which means if I plug in 1/2 into the polynomial, I should get a remainder, which is 1. And let's just solve both of these. So I'm going to put the polynomial down here. So P of 1. So let's just work out P of 1 first. So that is going to give me 8, 1 to the power 4, plus A, 1 squared, plus B, 1, minus 1, equals 9. So luckily, all of them, they are 1. So 8 plus A plus B equals 10, and A plus B equals 10 minus 8 is going to be equals to 2. So that's equation 1. Got it?
Yes, sir.
Okay, now I'm going to do for 1/2. Same thing. So 8 1/2 all to the power 4 plus A 1/2 squared plus B 1/2 minus 1 equals 1. Let's just work this out. So 8 times 0.5 to the power of 4, this is 1/2. Okay?
Yes, sir.
Plus 1 squared is 1, 2 squared is 4, so that is 1/4a plus 1/2b equals minus 1 when moved to the other side. That's going to be plus 1, so 1 plus 1 is 2. I simplify this further. 1/4a plus 1/2b equals 2 minus 1/2, which would be 3/2. So 1/4a plus 1/2b equals 3/2. Now multiply the entire equation with 4, which is the LCM of 4, 2, and 2. The entire equation with 4, so 4 times this is going to give you just a. 4 times b/2 is going to give you 2b. And 4 times this is going to give you 2 times 3, which is technically 6. That's equation number 2. I'll be solving both of these equations simultaneously. Okay?
Yes, sir.
So a plus b equals 2, and a plus 2b equals 6. I'll be subtracting both the equations here. Cancelled out. B minus 2b is minus b. 2 minus 6 is minus 4. Therefore, b equals 4. Once I have the value of b, I can use either of these two equations to work out the value of a. Let's just use the first one. So a plus 4 equals 2. A is going to be equals to -2. So therefore, the polynomial is 8x to the power 4 plus ax squared, which is minus 2x squared, because a is minus 2, plus bx, which is plus 4x, and minus 1. Okay?
Yes, sir.
Got
Yes,
it?
sir.
All right. Now, quick recap on factor theorem and remainder theorem so that you don't mix them up. Factor theorem was, if I give you a number, or you decide a number, you look for a number starting from 1, -1, 2, -2, 3, -3, plug that into the given polynomial. If it is giving you 0, it means that number change sign, put it with the x, and that is going to be one of the factors of the given polynomial. And if I tell you the factor that of a given polynomial, and you change the sign of its constant term and plug that into the function, that would definitely give you 0. Okay? Remainder
Yes, sir.
theorem is kind of this one. See, if you change the sign of this, okay, if it is a factor, if I divide a polynomial with a factor, what do I get at the end? 0, isn't it? You see? Change the sign, put it into the polynomial f of k, that's giving you 0. But that's same as remainder theorem, isn't it? Change the sign, f of k, this should give you 0, or the remainder. Now, if this is a factor, it should give you 0 as a remainder. If it's not a factor, it will give you some number. So that's what a remainder theorem is. There you go. Change the sign, put it into the given polynomial, that should give you a remainder. In this case, it was 40. If x plus 3 was one of its factors, it would have given me 0 as a remainder. Okay?
Yes,
Got
sir.
it?
Got it.
So let me summarize this now. So if you have f of x, whatever it is, and if you have a divisor, let's just say x minus a, then f of a, which you got from here, change the sign, plug it into this, so that will give you f of a. F of a will always give you a remainder. Remainder is going to be 0 if x minus a is factor. And remainder is going to be non-zero if x minus a is not a factor. So that's the main concept, which I just summarized. Yeah. So this was explained in different perspectives here. This one, if it's a factor, change the sign, put it in the function, it should give you 0. See? Why? Because it's a factor. If it's a factor, you know the remainder is going to be 0. But sometimes you don't know if it's a factor or not. So whatever the factor remainder is, you should be able to get that as an answer. Okay? So that is
Yes,
actually
sir.
a factor and the remainder theorem. Now, let's just talk about the factorization. So you studied about different techniques about the factorization in your IGCSE and the previous Pure Mathematics 1. Over here, I was telling you how to factorize the cubic equations in your IGCSE syllabus and in the previous uh, uh, part of the Pure Mathematics. We never learned about the factorizing, how to factorize a cubic equation, a full form of the cubic equation. So we can use these ideas about the factor theorem in order to factorize a polynomial. Okay? So
Yes, sir.
for example, I have x cubed plus 4x squared minus 11x minus 30. Okay, so let's just say, okay, x plus 2 times x minus 3 times x plus 5. So these are all 3 linear factors. These are all 3 linear factors of this cubic one. Okay, and let's just say I've got another polynomial, which is 2x cubed plus 3x squared plus 10x minus 6. The factors of it, they are 2x minus 1, x squared plus 2x plus 6. Now, one of the factor is linear, and this is quadratic. For this one, you should check that if you're able to factorize this further or not. Now, this one, you won't be able to factorize it further. So this is a quadratic further for a factor which cannot be factorized any further. Now, how can I actually go from here to here directly? So we'll be using actually a factor theorem. Okay. So let's just see how can I use a factor theorem. Let me just take you quickly back to it. If you remember a factor theorem, if you plug in a number, if it's giving you 0, from there I know it's one of the factors. Remember? So all we have to do is look for one factor. Once I have one factor, let me just take you to the first part here. Over here, the examiner asks you to divide this with this. This thing was given to you, isn't it? X minus 2. So you were provided with x cubed plus 6x squared minus 9x minus 14, x minus 2 times x squared plus 8x plus 7. So if you multiply both of these, you should be able to get this, isn't it? Now, one of these was given to you by the examiner for the polynomial division. But what if none of these is given to you? So all you have to do is start plugging in 1, minus 1, 2, minus 2, 3, minus 3. For this particular question, once you plug in 2, you should know that this is giving you 0, which means x minus 2 is one of the factors. Then you divide this polynomial with the x minus 2, and you will have another factor from there. Got an idea?
Yeah. Yes, sir.
Okay, so let's just say I've got a polynomial x cubed plus 4x squared minus 11x minus 30. An examiner is asking me to completely factorize this. I'm going to use an idea about a factor theorem here. So a factor theorem says x minus p is going to be the factor if f of p is actually 0. Okay, so let's just look for the number p. So let's just start, as I stated earlier, so I'm going to put this function into my calculator. So x cubed plus 4x squared minus 11x minus 30. So I'm going to calculate for different values of x. So let's just say I'm putting in 1 first. That's giving me minus 36. So I'll just make a note for this in my rough work. Okay, so when I plugged in 1, it's giving me minus 36. Now let's just plug in 2. Oh, sorry, minus 1. So if I plug in minus 1, it is giving me minus 16. Okay, now let's just plug in 2. Okay, when I'm plugging in 2, it's giving me minus 28. Hit calculate button again. Now I'm going to plug in negative 2. Got it. Boom. And negative 2 is 0. That's what I'm interested in. But I need to show my work on all of it. Okay. So I'm going to do 1 cubed plus 4, 1 squared minus 11 into 1 minus 30. And I know the answer for this one is negative 36. Then I'm going to do minus 1 cubed plus 4 times negative 1 squared minus 11 times negative 1 minus 30. And I've already worked that out. That's minus 16. Now I'm going to do 2 cubed plus 4 into 2 squared minus 11 into 2 minus 30. And that I've already worked it out. That's negative 28. Now I'm going to plug in negative 2. Negative 2 cubes plus 4 times negative 2 squared minus 11 times negative 2 minus 30. And this is giving me 0. Therefore, x, change the sign of minus 2, plus 2 is one of the factor, okay, of
Yes, sir.
x cubed plus 4x squared minus 11x minus 30. So which means I've got x plus 2 times something equals x cubed plus 4x squared minus 11x minus 30. Now I need to work this another factor. For that, I'll be dividing this with x cubed plus 4x squared minus 11x minus 30. So let's just divide it. And for that, I'll be using long division method. So x cubed plus 4x squared minus 11x minus 30. And I know x plus 2 is one of its factors, isn't it? Okay, so I'll be dividing this with the given polynomial. Let's just see. X squared, that's going to give you x cubed plus 2x squared. And change the signs. You got 2x squared. Pull down the rest of the things as it is. All right, now x times plus 2x is going to give you 2x squared. And then 4x. And change the sign. Subtract it. That's negative 15x. And then negative 30. And x times negative 15 is going to give you negative 15x. 2 times negative 15 is negative 30. And change the signs. Boom, you got 0. So that's another factor you got on top. So another factor is, therefore, x squared plus 2x minus 15 is another factor. Now we need to check if I can factorize this further, because this is a quadratic one. So 15x squared, negative 15x squared. But for the two numbers, when multiply, you should get negative 15x squared, and the difference of the two numbers should give you 2x. I don't think so. There is any such number. Okay, so this cannot be factorized. Therefore, x cubed plus 4x squared minus 11x minus 30 has two factors, x plus 2, which is a linear one, and then x squared plus 2x minus 15, which is a quadratic one. Got it?
Yes, sir.
Oh, actually, it is factorizable. Sorry. It's 5x and 3x. Sorry, how could I miss that? Okay, so I'll factorize this further from here. So that would be x squared plus 5x minus 3x minus 15, x plus 2, x plus 5 minus 3, x plus 5, and x plus 2, x plus 5, x minus 3. So you've got three factors of this cubic function. Got it?
Yes, sir.
That's it. Okay, so you can practice this. I'm giving you a question. You can do that later on. Okay?
Okay, sir.
So f of x equals to x cubed plus 6x squared minus 9x minus 14. I want you to factorize this. You should be able to get exactly same type of answer, all three linear factors for this one. Try it after the lesson, for the practice, okay? And that's it. That's all about the first chapter of the book. You can start practicing the questions from your book as well. Okay? Any
Yes.
questions?
No, sir.
Chala. ठीक हो गया बच्ची. Take good care of yourself. Inshallah, see you in the next lecture.
See you, sir. Allah Hafiz.